Hello guys, today we'll try to find the pi value through an interesting rule. First, let's know there is one interesting function called arctangents. From 1 it will be pi over 4. You remember it, yes? It is inverse of tangents. And what is interesting here, you have 1, any power will be 1, right? Uh, it means we can use it in series like Taylor series and so on. And it will be 1 is our power, negative power. It's very interesting because we have one good thing here and pi over 4 here. We'll try just to evaluate it and multiply by 4. I get 5 pi. Okay, first let's use one interesting fact. We'll try to take its derivative and then integrate it. The derivative of tangents in the axis of tangents will be equal to what? Will be equal to cosine squared, but we are going to get tangents here. Tangents is sine over cosine, as far as move it into denominator, local denominator. Use it as sine square plus cosine square, and we got it tangent square plus 1. Tangent goes from minus infinity up to infinity, that's why let's remake it to some letter to x. Yes, let's write tangent x goes to x. Just like this. Okay, now we got its derivative, and wait, let's try to make it like a row. Okay, what can we do? We have 1, but denominator is 1 plus x squared. Let's try to add a day and subtract x squared here. And wait, I can see something interesting. Can you see it? Okay, this is our denominator. But this is the same one, but minus 1 times x squared. You haven't got it? Okay, let's call our function t. Now we got they are equal to each other. It means t equals to 1 to be 1 minus x squared times the same stuff times t. We wouldn't like to find t, we just would like to write it is equal to what? It is equal to 1 minus x squared times what? X squared times 1 minus it to the plus x4, and so on and so on and so on. Yes? Have you got it? You'll go up to infinity, each power, in each even power, and so on and so on and so on. Okay, let's try to integrate it and get the same arctangents from x. Okay, integrating both sides. Integrating both sides. We will get x minus x cubed over 3 plus x5 over 5 and so on, so on. You know how to do polynomials. I will say I'm bad in integrating, but to polynomial integrating it's very simply. Okay, and what is our mistake here? We forgot a constant. Yes, we forgot a constant. But wait, will it be equal to 0 or it won't be? Because this row is so good. Okay, let's try. 0 in this row will be 0, right? And arctangents from 0. Also, equals to arctangents, if you can remember. I will make it. This is arctangents because of derivative integrated, the same function plus constant 2. But let's say from 0, arctangents is sine over cosine, right? 0 over 1, it is 0. And here 0, 2. It means constant equals to 0. Okay, we can write it, wait. You can write plus 0 if you wanted, but I wouldn't like to write it. That's why let's clear it, right? Okay, what's next? Now we will try to, as I told, it is almost just like the Taylor's rule. Yes, Taylor series, sorry. Okay, let's try to do an interesting thing. We'll use 1 here and get pi over 4. Yes, it is infinity row. Okay, let's multiply both sides by 4 and clear this side, right? Okay, let's try to use calculator to make this function. Hello. Okay, I wrote something like this up to 13. And well, this is approximately pi. Yes, I know only one digit is correct, a second is almost correct, but it is pi, right? Something bad. Do you feel it? I can feel it too. Velocity of this rope is very slow because 1 in each power will be 1. What if there would be 1 over 2, 1 over 5, and so on? It will be closely. Each term will be closely because 1 over 5, for example, the 7th power is less than 1 in the 7th power. And power goes to infinity. Each term will be smaller. There's one interesting guy, as I remember he was Leonhard Euler, who saw it too and told, just like he told, I'll try to find two numbers a and b which are integers and quite large, and we'll get 1 over a plus f tangents plus 1 over b tangents equals to tangents of 1. It will be the same number here. You will get two rows cancelling from each other, but the velocity uh, of coming will be very high. Okay, let's try to do this too. We will get tangents from both sides, right? Tangents from two angles. I wouldn't like to tell what is this. I told before it in my past videos. Uh, I'll make a hint. It is sine over cosine from functions. I told about it yet. I don't say it equals to this. Okay, but this is still equal to 1. 1 still equal to, it means numerator equals to denominator. Denominator is not 0. It means a times b is not 0. Okay, is not 1. Sorry. Okay, let's try to make it. Okay, common denominator here is ab. A plus b equals to ab minus 1. Let's try to get all the solutions. We can try one interesting thing. You can ask me to do to evaluate a from here, right? And try to uh, get try to what? So sorry, my English runners. And try to find all the possible integer b values. But it is slow. Let's try to use something another. You move it all on the one side, and if you have enough experience, you can see it is one interesting function. For integers numbers, it is very important. Firstly, let's try to get a from here. A equals to a times 1 minus b. But let's try to do something with this 2. We will plus, we will cancel b. No, we will cancel 1 time 1 minus b, so I remember well. Let me check. What is this? I'm sorry, some technical problems. Okay, for a and b, this is the same, but plus 1. Here to minus 1. Okay. Plus 2. Now they are the same. Okay, we got multiplication of two integers numbers plus 2 equals 0. It means this is equal to minus 2. Minus 2 you can write as minus 1 times 2 minus 2 times 1, and use all them here. For example, let's take 2 and minus 1. You'll get a equals what? A equals to 3, and b equals to, what is it? 2. Okay, what about other solutions? There will be no more in the absolute value than this solution. Because what? Because if you rewrite it minus 2, you will get a distance between them shorter than here. And plus 1, for example, or plus 2 even, it will be more shorter here too in the absolute value. Of course, in the absolute value, it is the greatest solution. Let's use it in our series, in our role. I'll write it as a normal sum, right? As a sum from 1 to infinity in the axis of a of I to I minus 1 right here, right? 1, 3, and so on. 5, for example. 1 over 3 is our x here. It's the power of what? 2y minus 1, because the first number will be 1, second will be no, the same as our denominator, and minus 1 is the power of y minus 1, because digit changes. First number will be 0, will be nothing, plus. Second number will be 2, and 1 will be 1, she's added, is minus, and so on. Okay, let's make it to the one sum, because the denominator is the same. Okay, you got it. Also, you can rewrite it as two sums from plus digit from minus digit, but I would like to leave it as is now. Okay, this is a very quick role to get pi.